Richard Patterson.
All those transitions and animations I'm going to lose. Right, hi, I'm Richard Patterson. I'm a network design engineer over in the UK for Sky. You guys may know of us as a satellite TV broadcaster who show you little men running around a field kicking a ball around. But we are also an ISP. We're the second largest ISP in the UK, behind the incumbent BT. And we have about 6 million residential broadband subscribers. The majority of those are terminating on our own kit, so our own DSLAMs inside unbundled BT exchanges. And we use PPPoE for terminating those. The remaining bunch are on sort of what we call an off-net. They terminate on BTs, VDSL, MSANs inside their cabinets on the street. Those we use IPoE native for termination. They get pseudo-wired across our metro back to the same BNGs as we're using for the PPP. And they happen to be 7750 Nokia SRs for anyone interested. That's roughly what it looks like. You guys know how an ISP looks. We're using 6PE across the core. Nothing fancy there. We have our own on-net CDN and lots of peering in transit. So the way that we've deployed V6, we've gone straight for a native dual stack. We made the decision not to use public addressing on the WAN. We've gone with link local across the WAN interface. We didn't want to burn fibs, or we didn't want to burn resources on our BNG, so we went that way. We've put a /39 per service, so when I say there was IPoE and PPP, each one of those services gets a /39 per BNG. And then we allocate each customer a dynamic 56 prefix allocation. We say dynamic, but unless the client sends a release or it changes its DUID, if you come back within 7 days of the lease time, you'll get the same prefix. So we do see a lot of third-party CPEs that send DHCP v6 releases, which tells us to give away that prefix, so it's as expected from us. We're then using Slack, so stateless address configuration on the LAN side. We're just using the first /64 of that 56 right now, there for future use, or if you want to bring your own CPE, you can do whatever you want with the remaining subnets. We also decided to advertise a ULA prefix on the LAN side. So for those not aware, it's like more of a RFC 1918 type V4 kind of private address range. It's routable, but it's not globally routable. Well, shouldn't be. The job will yell at you if he sees it. To do the enablement, we obviously had to have all of our BNGs up to the right software release and pre-configured. We have about 120 odd of those around the network terminating subscribers. So there's quite a few to get up to speed with configuration. We then obviously had to dual stack our peering in transit and our on-net CDNs and all that stuff. We needed to have comparable routes for both V4 and V6. We could not turn on V6 for all of our customers and then have them instantly turn around and complain that their internet started going slow. We wanted to have per user granular control of when we enabled these customers. We wanted to target which customers to turn on, and when to do so. So we wanted to be able to say, okay, we'll do the PPPoE ones first, and then we'll do IPoE ones later. We wanted to target which CPE we're turning on. And obviously, we needed the ability to actually exclude misbehaving devices or CPEs. We did this via using a VSA, vendor-specific radius attribute, inside the access accept, which comes back to the BNG. So we either tell the BNG, here's a v6 pool name, DHCP pool name for you to use, or we don't. Now we started this a bit of a soft launch back in July last year. So we ramped up pretty quickly. We got to about a million customers turned on by September. But then you'll see it plateau. We paused. We stopped for about 6 months. Why did we do this? And I've lost all the animation, so you've lost all the element of surprise. But so basically what happened was our Anycast platform the load increased quite substantially. Now there are two things on, so we have about 5 Anycast sites with load balancers and servers behind it, and it does various things, specifically for us including radius authentication, and also recursive DNS. So we'll start with recursive DNS. Obviously each host now each host resolution sends a single A query as well as a quad A query. Not unusual, we expected this. We had a plan for capacity, and we were going to throw more servers in there and do upgrades and all that sort of stuff. What we didn't anticipate was that this load increased a lot faster, and it wasn't following our enablements. It almost doubled pretty much overnight, or within a few weeks. It took us a while, and then we realized that it wasn't actually following our v6 enablement path. It was as soon as we upgraded the CPE firmware to handle to the v6 capable firmware that all the end hosts started sending these quad A queries as well. What happens is most OSs, as soon as it gets a non-linked local address, so in our case all those ULA addresses that we're advertising, they'll start sending the quad A's. The notable exceptions are there, Android and Chrome, which I don't necessarily agree with, because what if you wanted to build like an intranet or something out of private ULA addresses? You're more than entitled to do that. And as a complete side note, don't expect Chrome to work on your ULA private network, because, yep, that's Google's v6 recursive DNS server hard-coded in there as a connectivity check. Yeah, I don't know what the hex is. Anyway, so moving on to the radius authentication problem. For our PPPoE subscribers, those not too familiar with PPP, there's a little swim lane up there for you. We don't care what you put into the CHAP username and password. We do what's called port-based authentication. We do that with the information that the access node, so in our case our DSLAMs, will insert into the PAD-I on the way up to the BNG. Can do remote ID or circuit ID. The point is that PPP will come up and authenticator will come up before we even get to the DHCP v6 solicit process. So we already know who the customer is, they've already got a session, not a problem. Which is why we started the rollout with our PPP subs. We did a lot of, most of those 1 million you saw before were PPP first. We then moved on to IPoE. And as nice as IPoE is, all native and pure without its things, it's not without its foibles. So we do subscriber termination with DHCP v4 option 82, or more specifically the sub-option 2 remote ID, which is a free text field. We can put in whatever we want. OpenReach's VDSL DSLAMs will insert this as that DHCP v4 discover comes through their relay agents onto our network. However, they don't support the v6 equivalent for the entire VDSL footprint, which makes that pretty much useless for us. We can't know who the v6 solicit's coming from. So thankfully the Nokia SR has a nice little feature called IPoE linking, which will take the v6 solicit within a few seconds of the v4 discover, and it kind of knows who it's coming from, and it's pre-authenticated already, so we don't have to worry about that. The problem is that it's not, you can't guarantee that that v6 solicit's going to come in within those few seconds. It may get out of sync or do whatever, so we need another way of authenticating these v6 triggered authentication attempts. So again, the SR comes to the rescue with being able to run Python. So now all of our BNGs have this nice little Python cache thing on there, which takes the v4 option 82 information, stores it, and then will artificially insert it into any v6 triggered radius access request. So we know who it's coming from. Problem solved for that one. If you're lucky enough to happen to have an access node which can do v6 LDRA or lightweight DHCP relay agent, and it will insert that information for you. The circuit ID doesn't exist, it's now been replaced with interface ID, but we weren't using that. We were using the remote ID, which thankfully is there as option 37. The issue with this is, it's already skipped through to the issue, but as you'll see, there's an extra 4 bytes appended to that remote ID for the enterprise ID. Now, we don't really care whether that subscribers come through a Huawei MSAN or Nokia or whatever. We just want those remote ID. So now the problem is we needed extra logic in our Radius platform to actually identify whether this access request authentication attempt was coming from a V6 triggered one or a V4. If it's coming from a V6, strip off those 4 bytes and you're left with it. That's going to be vendor dependent, up to you guys of how you can do that identification. That's another little gotcha. So we'll move on to CPEs now. We had 8 different kinds of CPEs, the majority of which were developed in-house, which is both a blessing and a curse. And I say that because I don't think we'd have quite as many potential issues if we'd gone straight off-the-shelf CPE, but then we may not have had the same firmware, features available, or the ability to fix any issues that potentially could have arisen than we did in-house. One of those issues that we had was the DHB v6 client wasn't backing off as we expected it to, or as the v4 client does. If you cannot get a prefix, don't keep hammering our BNG. We just nicely, gracefully back off. And then that RFC 3315 does specify a back-off algorithm when the client does not receive an advertise back from the server. The problem was we were sending back an advertise. We were just sending back an advertise with no prefixes available. So it receives the advertise and it keeps trying, and it keeps trying. Hence the massive increase in load on our Radius authentication platform. We was doing that because you remember earlier on we were using that Radius VSA, the DHB v6 pool name, as the enablement process. So obviously we tried to convince them that the solution to this was actually just turning on v6, stop not giving the pool name and actually just turn everyone on. They didn't really have a bar of that, so we did have to pause and solve things before we turned them all on. So Python again comes to the rescue, and we had a little Python script in place there to just sort of block all those requests that we didn't want, which we then now have to remove once we got full enablement. The next question we had with the CPEs is, do we or don't we enable a stateful firewall? Obviously, it's a question for some people. For us, it was a bit of a no-brainer. We could not have a stateful firewall for all our customers. We'd probably have a lot more angry people than we would if we didn't have it. And we did. So we do implement a stateful firewall. We decided to allow unsolicited inbound IPsec, which helps with applications like, platforms like the Xbox One, which uses IPsec over IPv6 quite a lot for peer-to-peer communication. The next issue that we have with this is there are UPnP functions. So like in v4, you have a UPnP to open up, not just the DNAT, but also the firewall pinholing. In v6, they do exist, but they're still quite new. They're specified in IGD2 spec by the UPnP forum. Our CPEs didn't support them, and I don't know which ones do at the moment, but also you need applications to support this new function to open up the v6 firewall. So at the moment, there's that lack of feature parity there. We will actually have worse end-to-end connectivity on v6 without these dynamic firewall UPnP functions until CPEs and applications catch up with that, which is kind of ironic given people think that v6 is this globally addressable, routable, end-to-end communication model. We had other issues inside the house. We had other misbehaving devices. Specifically, we sold these sort of layer 2 Wi-Fi boosters. They're kind of special. They're not just a normal layer 2 access point. They did special things, but they broke v6. And they broke it in such a way that end hosts would still get a v6 address, but it would target any actual communication, any connectivity. So we really didn't want these customers getting a v6 address, so we had to explicitly exclude anyone who had these Wi-Fi devices. So it's a very good thing that we actually ended up, our implementation model did have that granularity. If we just let anyone jump on as soon as they had the firmware, it would have gone through the roof. Moving on to the next piece of the puzzle, CDNs. So we obviously have, as you guys probably do, a whole bunch of GGC and Netflix caches or whatever other CDNs you guys have. We started noticing that the Google's V6 report had the UK at a slight detriment in V6, so an extra 10 millisecond delay for V6, and this impact value, which is, they don't really give you much information about what that impact actually means. But as we were the biggest V6 rollout in the UK, we kind of were pointing the fingers at ourselves and thinking, why are we doing this? We thought we'd done everything properly. We've got all our pairing and transit all stacked, and our GGCs are all V6'd. We then started having a look at our GGC platform, and we were noticing that the switches that our GGC servers were connected to, the FTP entries were timing out, which is obviously suboptimal. And it turns out that Google, for whatever reason, security quote unquote, decide to only send unsolicited neighbor advertisements. So they won't respond to a neighbor solicit, which means the MAC address times out and you lose connectivity and bad stuff happens. Thankfully, the Cisco switches we were using have this little feature there, IPv6 NDNA glean, which allows it to glean the MAC address of an unsolicited NA and install that. Another CDN, $CDN, started deciding that 0/0 was geolocated in the US. Bit presumptuous, but... And then log files. Not really CDN related, but another ancillary service. What happens when your tool, your script expects to see a v4 dot decimal notation and then receive something crazy like 2001 : deviate : blah. What are all these colons? Segfault was obviously not the correct answer. Some more things. I'm not sure how I'm going for time. I've got heaps. I feel like I'm rushing through it. Cool. So third-party CPEs. We have a few of those. We don't explicitly allow it, but then we just turn a blind eye to it, I believe. pfSense and other, I believe, WRT forks, even though you were configuring them to use stateful DHCP-v6 with prefix delegation on the WAN side, they were just not sending, they were not starting the client until they received an RA from the BNG, which obviously puts us in a bit of a stalemate because our BNG hasn't authenticated a customer. It's not going to start talking to a customer until you send a DHCP-v6 solicit. So I believe pfSense are working on that. Hopefully the others are too. Back to our in-house router now. We had a firmware upgrade for these v6 stuff, which actually broke 6 and 4 tunnels. So e.g. Hurricane Electric tunnels. Thankfully, it was nothing to do with the actual v6 deployment. So it wasn't anything that we did with the v6 that caused it. It was sort of another bug that got introduced with a driver update for the Broadcom hardware FastPath chipset stuff. But it doesn't look good when we're turning on v6 and we're actually actively breaking someone else's v6. It upsets some people. The next little story is quite fun. A very large bank over in the UK moved some of their web front-end platforms over to a new shiny thing with some F5s, and they got F5 to be the consulting engineers and deploy this. And apparently we broke their stuff. We broke a bank, allegedly. Their response is, well, Sky is unique and the only one affected, so it must be your fault. Fair enough. Doesn't matter that you guys just migrated to a new F5 platform. What they were doing was the F5 platform was silently discarding any DNS query for any unknown records, instead of sending back what you'd expect in the next domain. So this is considered by F5 to be best practice. So what was happening was our recursors were blacklisting their authoritative name servers, because you're telling us to use these authoritative name servers for this zone, we are, and you don't respond. Well, that's a bit rude, so we'll blacklist you. And that's the quote we got from our vendor. lot of swearing, and yes, a bit of a differing opinions on best and worst practice. Right, and I'll, again, losing all element of surprise, I'll end on something slightly happier. The too long did not read. A few weeks ago, someone messed something up, and they broke v4, but v6 kept on working. We were using different root reflectors for v6, so something to be said for the lack of shade fairing there. That's it. So rush through things. Sorry. Feel free, if you've got any excuses, to tweet that address. And if you've got any more questions?
Thank you.